Hi, my name is Karl Kilborn. I'm co-president and co-founder of 3i. And for the last 27 years, our mission has been translating cool developments in biophysics and physics into tools that are more accessible by biologists for designing some very interesting experiments. I'm speaking to you from our new facility in Denver, Colorado, that we opened up about 2.5 years ago. And in particular, I'm in our multi-photon development room, where we develop tools for multi-photon imaging and multi-photon stimulation. In particular, we're in the process of setting up a system for all optical electrophysiology that combines our next generation Nuvo phaser computer-generated holography system that supports 3D shot and 3D temporal focusing for very accurate targeting in neurons with our Vivo multi-photon microscope. But in our facility in general, this is where we gather teams of people, including our mechanical, optical, and electrical engineers, our physicists, our product managers, our software developers, into building a lot of really cool instruments. These range from our lattice light sheet microscope to our cleared tissue light sheet microscope to Mariana's spinning disc confocal to the equipment I have right here, Vivo multi-photon and Nuvo phaser. And here in Denver, we do a combination of original development, where we're designing things entirely of our own design, to things where we're adapting designs that were first developed in research labs, be that at Genelia Farm or Sorbonne University or Rockefeller, and building them into more robust, useful components for biological labs, and also where we work on some specific research projects, such as one in the process for building a microscope that may go out into space soon.
My name is Osnat. I'm a research scientist at 3i. I work in Paris at the Vision Institute, where our offices are. At 3i, I'm the product manager for our holographic product line that we call Phaser. We have been selling and working on developing holographic products since 10 years now. We're constantly adding new technologies, new licenses that we own, and here in Paris we are also sharing a facility with the Vision Institute and mainly the group of Valentina Emiliani, where we can host collaborators, potential new users. We can do demo, and we also use that system to do our research and development work on Phaser. So here is the lab that we have at the Vision Institute. Please come on in. So here we have our Vivo multi-photon open platform, and that we use with an open stand that is here, where you can see that we have a very large empty space below the objective. So that design is very well suited to do in vivo experiments, both on rodents, fish, or even bigger animals. So I'm going to describe you the 2P imaging path. We're using here a single wavelength imaging lasers emitting at 920 nanometers. And we're sending the beam here, where we have a resonance scanner, and the beam goes up to reach two galvos that we can see here, and then the beam is going through the whole microscope to reach the objective. We're using also a beam combining cube to combine two different input beams, one from the imaging side that I just described and another one from the photostimulation side, and that's the path that we'll just show you now. Here you can see the last version of our phaser product that we call the Nouveau phaser, and so we're using it with photostimulation lasers emitting at 10 nanometers. We are using an AOM based power modulation device that we developed at 3i, and we're sending the beam to the Nouveau phaser path. So the main pieces of hardware of that product are the two SLM here. We have one here, a second one here, and a diffraction grating. So with these main devices, we are able to provide a system that can perform 2P holography with temporal focusing in 2D, and 2P holography with temporal focusing in 3D, as well as 3D shots. So to switch between the different configuration, we just need to switch between the flipper mirrors, and in this configuration we have the 2P holography only path, where the beam hits the first SLM and then is reflecting to all the lenses and mirror and gets out of here to reach the microscope. If I switch to mirrors here, then now we have the diffraction grating that is included in the path. So we are able to do 2D temporal focusing. Then the rest of the path is the same, and the beam goes to the microscope here as well. Now again, if I flip two other mirrors here, then in this case we have the second SLM that is now also included in the path, and that will allow us to do 2P holography with temporal focusing in 3D. So now if we want to insert the 3D shot path, then it's also possible, and in this case we're just adding a mirror here to bypass the first SLM, and the beam hits the grating here and then travel all the way to the second SLM, which is the SLM that will be used for 3D shots. And same, the beam comes out of the phaser and is combined to the imaging laser.